Microsoft just made TypeScript 10 times faster. That's what they say, at least. But that's not the interesting part to me. The interesting part is what they rewrote it in. Microsoft owns C Sharp. It's their language, in house, decades of tooling built around it. It's also what's called a garbage collected language. It means the language is automatically cleans up memory that you're not using anymore so that you don't have to manage all of that by hand. And I know I don't want to. So keep that term in your pocket. It will matter later. Microsoft didn't touch C Sharp for this. They went and grabbed Go instead, a language that they didn't build. So why not just use what you already own? That was my biggest question when I started researching all of this. So I dug into it because, your girl's nosy and I love a good answer, especially a tech-related answer. A quick bit of context first. TypeScript has been around for 14 years now. It's on GitHub, something like a billion downloads a month on NPM, which is honestly insane. And up till now, the compiler, that is the program that takes your TypeScript code and turns it into something that's, actually able to run, it was itself written in TypeScript, which means it's basically, at the core, a JavaScript app, and it was running with JavaScript. So TypeScript writing TypeScript or TypeScript. That's basically the whole setup for this rewrite. And I will get into why that mattered in a second. So stick with me, because by the end of this, you'll know why Go beat both Rust and Microsoft's own language. TypeScript's compiler was self-hosted from day one, meaning that it was written again in TypeScript, the same language that it compiles. That was great early on, probably because, the team was able to use their own tool every single day and get that feeling firsthand about what worked, what didn't. But it also meant that the compiler ran as a JavaScript app. And JavaScript was not really meant for any of this kind of stuff. JavaScript runs on something that's called an event loop. Basically, it's a single thread by design, built to react quickly to clicks, screen updates, and a browser. It was never meant to grind nonstop through billions of lines of code on its own. The most common bug report that TypeScript would have was, quote, out of memory. Their sister project, VS Code, is 1.3 million lines of code, and type checking the whole thing on TypeScript 6 takes about 50 seconds. And if you don't code, 50 seconds might not sound like much, but it is when it comes every single time that you have to rebuild. And you're rebuilding constantly when you work, and that adds up to a lot of lost time very fast. Also, real quick, before I get into the language stuff, I actually made the mistake of thinking that Microsoft owned Rust. In case you're thinking it, they don't. Rust belongs to an independent nonprofit, the Rust Foundation. Microsoft's a major sponsor of it, which is honestly pretty cool, but they are not the owner. What they do own is C Sharp. It's their own language built, again, in-house, garbage collected with over 2 decades of tooling behind it. And they skipped that one too. So why? Now, I'm probably going to mispronounce his name pretty bad, let's be honest. But here's Hejlsberg himself on it. Quote, C# is a bytecode first, is not on all platforms, doesn't have a decade of hardening, and was not engineered that way, end quote. Let me actually unpack that instead of just quoting it at you. That whole line is basically describing C#'s shortcomings for the specific job, not Go's strengths. Bytecode first means that C# code doesn't run directly. It gets compiled down to an in-between kind of format that needs Microsoft's .NET runtime installed to actually execute. And historically, that runtime hasn't been available the same way on every platform. And, it doesn't have a decade of hardening means that C# specifically hasn't been proven over the years at producing fast, native, standalone cross-platform binaries the way Go was. That might sound like it contradicts what was said earlier, C# having 2 decades of tooling behind it. However, it doesn't. It's just 2 different things. I had to catch myself. C# is the language that has been around since 2000. It is plenty mature, but using C# specifically to build a native, ahead of time, compiled, cross-platform tool like this compiler is a much different beast. It's less traveled use case for it than enterprise or .NET application work, which is what it spent 2 decades getting good at. Now, Go, on the other hand, has been built exactly for this kind of systems work since it was first released back in 2009. But here's the part that I actually think matters more. TypeScript compiler barely uses classes, which is the building block of C#. They lean on that heavy. Instead, it's written in a functional data structure style, meaning that it's mostly just functions operating on plain data. It's closer to how you'd write JavaScript rather than how you'd write enterprise C#. It makes sense. I mean, at its core, TypeScript is JavaScript, basically. Hejlsberg said it plainly that Go is functions and data structures. So moving that code to C# would have meant fighting their own existing architecture the entire way rather than just matching it. Now, in raw benchmarks, Rust is faster than Go. No garbage collectors, zero cost abstractions. It's memory safe without the runtime overhead. And on paper, again, it clearly wins. So why didn't they go with that? The compiler's core data structure is called an abstract syntax tree. Basically, it's just a map of your code structure in a type checker. It's not some sort of simple, clean tree. It's full of circular references. Parent nodes pointing to their children, children point back to their parents, symbol tables reference check relations that reference right back to the symbol table. In a garbage collected language, you just do that. No extra work. It's quote unquote free in a sense that you don't have to write any special code to handle it. The language just cleans up after itself automatically, which is so nice. Now on Rust, on the other hand, the model will kind of fight you on this, in my opinion. Rust wants to know exactly who is responsible for cleaning up each piece of data. So two things pointing at each other will break that rule. You end up having to wrap everything in kind of like an extra tracking code just to make it legal, or hand build your own custom memory management system from scratch. Either way, at that point, you're not porting the existing code anymore. You're redesigning the architecture from the ground up, which is very costly. This is straight from the team back in a GitHub discussion from March 2025. Idiomatic Go strongly resembles the existing coding patterns of the TypeScript codebase, which makes this porting effort much more tractable. And again, as Hejlsberg said, Go was chosen as the lowest level language available. They did not say the fastest. It is the lowest level one that still let them keep garbage collection, because that was at its core, the requirement that they wanted. They were not wanting to compromise on any of that, which makes sense. I did see some stuff saying that they tried Rust prototypes, and in the end, it devolved into a write your own garbage collector strategy. I went and tried to find if there was any other information about that. I mean, it makes sense when you're looking for things like this. You want to be able to test out multiple resources to see what makes sense. But again, there's nothing super official about it. When someone pressed the team directly on why not Rust, Daniel Rosenwasser's answer was, pick the language that would allow us to port most effectively for this task. That's it. No further explanation on Rust specifically, or at least not publicly. Whatever the exact reasoning, the results back it up. Compiling VS Code went from around 50 seconds down to about 6.5 using Go's concurrency. Concurrency meaning that it ran multiple type checkers across different processor cores at the same time, rather than JavaScript being single-threaded. A lot can just happen at once. And if you push it further, it'll drop to 4.5 seconds. That's almost 12 times faster than a language that isn't even the fastest option available. This isn't really a story about Go beating Rust in a speed contest. It's a story about porting versus rewriting. Rust might get you there faster, in theory, sure, but only after a multi-year rewrite with the real risk of breaking compatibility for tens of thousands of existing projects that are already running on this. Go let them keep the same code, the same structure, the same algorithms, and just moved it to a different language. Basically, take the real, 10x improvement that you can actually ship over a theoretical 20x one that never does. And if you're paying attention, yeah, we've already answered this, but why not just improve TypeScript itself instead of switching languages entirely? And short answer, they have been optimizing the JavaScript version for years. However, JavaScript engines are genuinely fast for what they're built to do. They are still single-threaded and bound by garbage collection pauses. There's no path left to a 10x gain without going native. They'd hit a ceiling of what that language could give them. So the real reason, I think, why Go and not Rust and not even their own C Sharp isn't about raw performance at all. Go was a garbage collected language that resembled their existing JavaScript shaped codebase closely enough to be able to support instead of rewrite. When a tool is that is this widely used breaks, even just once, it is a trust problem. With everyone depending on it, a full rewrite just isn't worth that risk. All right. So if you like this kind of thing, me digging into the why of coding news and whatnot, let me know. Comment down below, give me like a thumbs up, subscribe. And if you're interested in anything else I talk about or just want to listen to me talk in general, I do have my podcast, which is Head First. I will include links at the end of the video. So go ahead and, if nothing else, drop me a comment and let me know. When is a time that your team chose porting over rewriting or the other way around? And did you actually feel like it was the right choice? I will see you next time.